It's right time to check your ability to solve geometric sequence problems. All right, that's video. It's gonna be short. Don't worry. We just need to apply the rules for geometric sequence. So at least 5 terms. I just skip that, and we just only need to be able to derive the formula for nth term. However, you can practice just by plugging different numbers, and that's how you can arrive to actually terms itself. So one more time, to generate terms of your sequence, so you need to run n starting from 1 and up to the last term in your given series. So for example, 5 terms, right, from 1 to 5, so from first to the fifth term. All right, so we did plenty a lot, and now we just switch to the formula for nth terms. All right, so let's do it. So 1 minus 1, 1 again, minus 1. So here is the rule how we can arrive to next term from the previous. All right, so we multiplying by a negative number. So every time multiplying by negative number. So this negative number is -1. So looks like, so the general term for the sequence can be expressed as, just remember geometric sequence, u1r to the power n minus 1. So successfully we can say that un's term should have the full formula. So 1, that's u1 times ratios -1 to the power n minus 1. Okay, so what we can do, can we simplify? Yeah, of course, we just leave n minus 1 power, so -1 to the power n minus 1, and that's it. Obviously, if you see the formula similar to that, it doesn't matter actually, because look, when you plug n equals 1, so here, for example, you will get 0, while here you'll get 2. In both cases, you will have u first term equals 1, and that means correct. Okay, so B, starting from -1 and right to 1. So in the same manner, we can say that the general un's term is going to have the following form. So -1 to the power, because the ratio is -1, to the power of, let's say, n, right, in total. Why? Because the first term is -u1, but you multiply by -1 to the power n minus 1. So using properties for indices, you just add the top parts here. So the top parts is just measuring 1 here, 1 and -1 will give you 0. So next line result is -1 to the power of n. Okay, so C, sequence C, let's do it. 2, 4, 8, 16, 32. All right, so every time we multiply by 2. So the formula stays for the nth term is 2 times ratio 2 n minus 1, or just 2 to the power of n. All right, so that's C. Okay, let's move next. So D, 2, -4, and 8. All right, let's try to figure out the same rule for geometric sequence. All right, so 2 times -2 to the power n minus 1. Okay, so that actually you can leave as it is. There is no way to simplify. There is the one way, but if you leave as it is, it will be also correct. So okay, 6, 18, 54. So every time we multiply by 3, okay, so that's why un's terms is simply 6 times 3 n minus 1. That's the formula. Okay, next, F, 6, -8, and 54, right? In this case, we multiply by -3, so common ratio is -3, and that's why the formula stays for the nth term is actually 6 times 3 n minus 1. Okay, that was this for f. Ratio, sorry, is negative, so negative 3 to the power n minus 1. Yeah. Okay, now let's move to g. So for 1236 multiplied by 3, so the first term multiplied by 3 to the power n minus 1. That's the formula. All right, so h, 2 negative 40. So we actually multiply by 7, right? By negative 7. So let's check. Yeah, it works the same. So negative 7. Again, we're just multiplying. All right, so the general formula for nth term is 2 negative 7 to the power n minus 1. Okay, and the last one, 3 minus 6, 12. So multiplied by negative 2. Yeah, this is the case. So we multiply by negative 2. And that's why un's term is 3 times negative 2 n minus 1. All right, so that's I. Okay, do we have anything else? Yeah, we have. It was in last. Okay, and this is the last g. Negative 16, 8. All right, we multiplying by negative 2. So looks like negative 16 times negative 2 to the power of 1, negative 1. So actually, it should be 1 over 2. So the ratio is 1 over 2. So negative 16, we multiply by the ratio 1 over 2. And that's also negative. Yeah, let's correct myself. So ratio is actually negative 1 over 2. And we multiplying by this ratio to the power of n minus 1. Okay, that's it.